Hey everybody, welcome to Live App Review. I am going to today be continuing with the payments contract, but instead we're going to change it to be a subscription contract. So what that means is that we're going to take a deposit and we're immediately going to start paying the deposit. So before, with the payments contract example, we would take a deposit and then we would allow the user to pay for it. That was in Live App Review 8. But here in Live App Review 9, we're going to work on a subscription contract. So we're going to take a deposit and then we're going to progressively take payments of that deposit over a period of 12 periods. So for 12 months. But in this case, we're going to speed it up and we're going to do 12 seconds. So you don't have to wait 12 months to see if it works. So I had a lot of trouble with the math, and this is actually take 2 of this video. But I'm going to see if I can still get the app going for you. So I think we still have the old contract deployed. So I was just going over how I was explaining how you could make deposits. So this is the previous example. So let's say we're signing in. I'm just going to do one here. So 297. $296. Okay, not paid. I could withdraw. And that should disappear. And then it goes back to 297. Let's do one more because I'm actually going to pay for this one. So we're going to deposit and now we're going to pay. But in the subscription contract, we're going to deposit and it will immediately start calculating how much I've paid. And then that's the subscription basically taking my money, but I will be able to withdraw provided it's before the actual end of the subscription. So remember, we're going to do 12 periods of 1 second each, simulating 12 months. So here I've not paid, so I'm going to pay. And now I can't withdraw anymore. So it says here, payment already confirmed. Okay, cool. So that's the previous example. Let's go to the contract and I'm going to walk you through how it's changed. So we still have a deposit here. We have the memo field. So what is it for? The amount. How much is paid is no longer a Boolean. It's a unsigned integer of a byte. So or no, it's I always forget this. It's 8 bytes. So did I actually mess that up last time? I think I did. Kept saying it was like, so a U8. I don't know. I think yeah, U8 is just a byte. Because it's 4 bytes in a 32-bit integer. Okay. Wow. I'm getting really tired. But anyway, this should be pretty quick because the contract's already done and I checked it out and it works. So we have the paid. So that's how many periods are paid. So we could have a sort of subscription protocol that spans many, many months. I'm going to assume you want to work in months. But this, you'll notice that this second calculation is basically going to divide, it's going to divide our timestamps into seconds. So every nanosecond, which is how block timestamps are measured, is 1 millionth of a second. So basically this gives us all the sort of the components that we need to calculate how many periods have been paid. The last piece is created. So when were we created in terms of time? So let's go through. So regular sort of contract setup, and then let's take a look at the subscribe method. So when you call subscribe, you are going to attach an amount, and that's the amount to pay for your subscription. So let's just assume that the amount is, enforced by some sort of arbitrary amount. And let me just double check all the streaming stuff. Yeah. Let's make sure that it is, or let's assume that the amount's enforced somewhere else. Let's just worry about this subscription payment kind of situation. And basically what's going to happen is the deposit is going to be put in with an amount. It's paid is going to be 0 to start, created at some block timestamp, and we're going to insert that. So now we're going to look at the withdrawal, but first it's important to understand the ping method. So we need to understand ping, because ping is going to update the actual deposit. It's gonna basically change it. So we're gonna go through. We're gonna get the deposit at the deposit index that we want to ping, and we're going to get a mutable reference to the deposit, and we're going to get the current timestamp, and then we're going to calculate how many periods have been paid. So what we do is we take the current timestamp minus the time it was created. So let's say we were in block timestamp 2 seconds, we would minus off if it was created in 1 second, and we would get 1, right? So that's 1 period. And that's, we get that by dividing by the second, and then we convert it to a U8, and we basically just kind of round it, and we say deposit.paid. So, well, we don't round it, we just truncate it, but whatever. Anyway, so it's going to end up as deposit.paid. So then we've crossed that period, we've crossed that threshold, we've paid for that first period. So if the timestamp that we created it at was like literally just 1 second timestamp, so like 1 million units, and then we were in block 2,000,001 units, then what would happen is we would do this calculation and we would end up with paid equals 1. So now we go back to self deposits insert, and then, we update the deposits. We go back to withdraw, and now we want to see in the withdraw if we can withdraw anything. So what we do is we go get the deposit again. And I probably could have passed it back here from ping. Probably should try to figure out how to do that, but I'm not going to do that because it's working now. So what we're going to do, the next thing we're going to do, we'll just separate this. We're going to assert that the deposit.paid is, it has to be less than the full period. So it could be 0, 1, blah, 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 up to 11, but not 12. And then otherwise the subscription deposit is empty, or subscription, fulfilled. I don't really know the language here about subscriptions. Now we're going to grab the portions that are filled. And I had a little trouble with the moon math here, but it's, it's okay. It's passable at this point. And then we're going to get the unpaid portion. So what is portions? So we're going to take the deposit amount divided by the full period. So we're going to take the amount. So let's say you paid 1,000 units. So let's sketch it out here. Let's say the amount was 1,000 and you divided that by 12. You would end up with 183.33 something, I think. Let's do that. 83, sorry. So 83, blah, 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 blah. And then if you did the unpaid part, you'd end up with full period. So that's 12 minus the deposit paid. So let's say we paid 1 period. and that's, you know, that's 11. So then what you do is you take this number and you times that by 11 basically, and then that's what equals, you know, how much you can withdraw. Okay. So sorry if I kind of went a little fast there, but it's not that interesting. You can stare at it like I did in my first take and try to make sure that it worked, but it does work. So what we're gonna do is we're gonna test it. So we've got make deposit, and we're gonna yarn test unit. So what we start in is we start in block timestamp 0, and we go into block timestamp 1 plus 1 second. What I'm going to do is I'm going to actually try to just do it on the edge there. I think it should work. Yeah, but what happens when we do this? When we do less than 1 second? So we failed because we expected that we were going to be paid, the paid units of the deposit were going to be 1 because we expected 1 second of time to pass, but it didn't equal 1. It equaled 0 because we didn't get past that first month or the first simulated month. So let's continue on with our tests. Let's add another test here. I've got the old tests. I'm going to get rid of them. Okay. So when we withdraw, this is a good point. No, the promise is there. Oh. Let's just test. Testing balances is really crap in this unit tester thing here. Okay, when we withdraw, what do we do? So if you withdraw, we also want to remove the deposit too. So let's do this. Let's mute. Let's do remove here. And then if we were successful, let's put deposits back in. So we're updating it like we did before. When we withdrew, we took the deposit completely out of the deposits that the user could check. So what we'll do is we'll make sure that the withdraw was successful. Oh no, that's not true, because yeah, we don't want to wipe that out actually, because we want the owner to have a record of at least a tiny fraction of the deposit. So what can we check in a unit test? Not much. So let's skip to a full-blown app test actually for this. So we tested, you know, a little bit. Let's skip to our app test and let's update our contract here, or our config. So we're going to go to config. I'm going to change the method. So we're going to change it to subscribe. Whoops. Yikes. Ping and withdraw. Get. I think I call it get subs. Sorry, I'm also on Clubhouse. Just listening in. Withdraw, subscribe, ping, get subs. Okay, contract hash. So this is now called subscribe. We don't need to add anything else because they're filled in for us. So Alice goes and makes a deposit. And then we get subs. Okay, so right now, live Ethereum AMA, Austin Griffith is talking about getting people involved into apps by basically giving them a little burner wallet, easy onboarding, super fast transactions. And then when they have something valuable, getting them into like, a real wallet and a seed phrase and all that stuff. But you all already know about that, don't you? Because you've been following my tutorials and you watched episode 6, Progressive Onboarding, where we took a single key pair and we allowed a user to mint 3 free NFTs and then sell those NFTs for real NEAR tokens, and then they could fund their own wallet. So you already know all this. You're ahead of the curve. I'm in the little clubhouse and they're talking about exactly what I've been teaching you. So keep listening. We will get there. That's what NEAR is all about. We're helping get everybody onto crypto and make everybody crypto rich. So let's finish up this this app test here. So Alice subscribes, gets subs, and we're gonna check the memo, and we're gonna check paid. Paid is gonna be equal to 0. So let's check that first one. All right, so here we go. We're gonna have to test deploy. So remember, running yarn test deploy is going to deploy our contract and make a new dev account, and then it's going to run this test. Sorry, make a new dev account, deploy the contract, then run the test. Okay, so that passed. So we have to, now we're gonna have now it's on testnet, right? So the block time's running. So now we're gonna check ping. Let's check ping. We've got our subscription out there in the wild. What is ping? Ping takes a deposit index, okay? It's kind of like this. So I'm gonna steal this actually. Okay. Now, this is a ping. I gotta screenshot this guy, sorry. I gotta go follow him later. Talking about living in Canada and having a privileged life so you don't need to care about decentralization. Brilliant. My brethren. I care about decentralization, but I think I care about it more in the context of, being, I guess, like unstoppable, anonymous, not having to worry about a bunch of bullshit legacy systems. I kind of worry about stuff like that. I don't want to be dragged down by, some Kafka-esque bureaucratic nightmare. Let's get back to it. Let's check this ping. Sorry for my little clubhouse musings with Matt Lockyer. So check deposits, get subs. So we don't know how much is paid after we ping, do we? So what we're gonna do is we're just gonna check the memo and we're gonna have to print it out. We don't know how much time has passed. That's the problem. I could keep track of time on the JavaScript side as well, but we'll see. Oh, I hit test deploy though, so there will be some delay there. Okay, so we pinged and then we printed it out. So paid is 3. So apparently, 3 3 seconds have passed. Let's do this though. That actually is going to be... We have to kind of keep a rough track of time. So then we're going to ping, and we're going to do const paid equals... Oh, God. Now we're going to check if paid, if we can simulate sort of, you know, what should be paid. I think in JavaScript it's going to be the milliseconds, so we need actually to do math.floor. So this is what would happen with the the conversion inside the smart contract. It should get converted to like a U8 and it gets truncated. Let's just keep that there for now. So now we don't want to deploy because that's going to take time. Don't want to keep you waiting. So we're going to check ping and see how much is paid. And then we're going to check and see if we can withdraw before we lose it all. Okay, so looks like that worked actually, the rough math of time calculating. Withdraw. The whole room just ended in Clubhouse. It's feeling very empty now. Okay, so await contract withdraw. And now let's do this. So we got created. Let's calculate paid again inside here. Paid deposits, get deposits. Oh yeah, we call withdraw. Okay, so here's what we have to do. Now this is crazy. So in order to test this properly, we have to pay 12 tokens. I'm gonna update my config here to give Alice 20 tokens when her account is created. We have to pay 12 tokens, and then we have to see how many near tokens we have back at the end. So we make a deposit of 12. And we see how much is paid, and then we have to go get Alice's state. So in order to get Alice's new state, we have to count.state. This Clubhouse room just died so hard, like just had this huge crash. And this guy was just like, is anybody excited about Flash Mints? Anyway, Flash Mint loan, whatever. Okay. Let's check this. I'm gonna get out of here actually, because it's just noisy. Okay. Just noisy right now. Okay, so we want to find out the amount before. So for some reason, I always have to go get a new account instance every time I'm checking the state. So, oh, wait, no, we just want to check the state back when you first create the subscription. Okay. So before the subscription, oh no, we know the balance. So we got 20, then we're minus 12, and now we just want to check the state, check the amount. Okay, and what do we expect the amount to be equal to? Oh, I don't know if we can do that one. That's going to be pretty crazy. So yeah, we'll figure it out. Here, format. Let's just print it out. We don't need all this. We just need to call withdraw. So we're taking back some funds. So we should have, I guess our test pass if we just have more than 12. Because we took some back. Let's see. Let's see. What happened? Uh-oh. Okay. Something's really funky with my console here. Oh, it's because it's cut off. Oh, whoops. Not gonna work there. That was an automatic import by the IDE. So that's not good. Oh, come on. Huh? Oh, it did work. Okay. So console log 0. So what is 0? The amount console.log deposits. Hello world paid 3 0. Oh no, sorry, that's state. Okay. Oh. Boy, I'm really doing some crazy stuff. Okay. Here we go. This should pass. So we know we just want to get more than 12. That's all we want this number to be, is we want the total amount that the user still has to be more than 12. It's 14. All right, so they didn't drain their account entirely. So we could even, if we really want to do, you know, the moon math and all that crap and make sure we do it right, we could do it right. Oh no. I hate this stuff. I never remember it. Never. To be greater than. I like it. Do you like it? I hope so. Okay. So now that we're done that, we can make our app and we're done. So we will make a subscription app where we'll have all this functionality. It's going to be fast and furious. We're going to have to go ping, ping, ping with our button. Ping, ping, ping. Okay. Everything checks out to me. So let's go back into our app and we have to make a number of adjustments. Most of it is still the same. So we know we want to make a deposit, but all of these contract methods have changed. In the interest of time, I'm just going to change the contract methods here. I'm going to handle ping. That'll make it easier. Ping, 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 ping. Handle withdraw. Okay. And actually, I'm going to fix that wallet thing where the wallet doesn't update. So handle payment, handle ping. I'm going to say ping sub. We're gonna go get deposits, load deposits. That's gonna be get subs. And paid is gonna be we're gonna do paid, and then we're gonna print out of 12. Okay. So we just modified the front end just a little bit to suit that new contract. Take out the deposit, load deposits. The naming around deposits is still kind of antiquated. Huh? Antiquated. Okay. But we're still gonna get subs. Now let's fix that wallet thing. How do we update the wallet? Let's see. I think we have to dispatch. So we need to get dispatch from here. So contract. And there's a helper method in the state here. Where is it? In near state. I'm gonna need to put this back over here. Get rid of some files. Test work, config works, contract works. So back in the near app state, there's a helper function. Oh no, there isn't. Okay. So export const. These are like thunky little state things. Get state. And we're gonna get the wallet out of the state here. Then we're going to update the wallet balance. Then we're going to update the wallet. Okay, so let's see if we can dispatch that from the contract. That would be helpful. So when we handle withdrawal, we want to see the amount come back into our wallet. Otherwise, as a user, we get a little freaked out. Where's my money, man? I won't even go into that Rihanna stuff. Yikes. All right, let's make sure that this is working. Okay, and just remember this piece of crap. I'm actually just gonna clean parcel cache, just delete that, and I got a little yarn fixer that fixes all my semicolons. I've been told some things about my semicolons. Matt, where's your semicolons? Okay. Come on. You can do it. I believe. It's so weird. I think it's having trouble here. Yeah. That should be an arrow function. That's why. It's having a little spaz out. Object assign. What? There we go. Okay. Having a little bit of a trouble there. Okay, so now remember, we are going to make deposits to a subscription. So we're just gonna say subscribe. Okay, I'm not gonna fill in the memo. I'm just gonna do, that's helpful. Good error. I'm just gonna pay one near. I'm gonna do the deposit, and the moment I do the deposit, the paid is gonna start calculating, right? So I'm gonna need to call ping with my access key. Oh, no, that's bad. That's wrong. What is going on? That's funny. Handle ping. Oh, well, it did go to 10 out of 12 right away. And now I can't withdraw. But why are we getting redirected? Oh, I know why. Okay. So I redeployed the contract. And then I signed in, or I did not sign in with this wallet. I was signed into the old contract. So I didn't actually have an access key for this wallet, but it looked like I signed in. So I got duped. I got duped by localhost. It's because localhost had the sign in from the previous contract. So right now, I should not be able to withdraw. I should get an error here. Payment already confirmed. Okay, wrong error, but still, you know, I should be able to just ping it. So 63 seconds have passed. Okay, that's wild. So now I'm going to subscribe with one near, and I am going to allow that, and I'm going to quickly withdraw. So 294.34. And I did it in 6 periods. So 294.34. Okay, the wallet update didn't work. Oh, yeah, update wallet not defined. But did you see that? 294.34 turned into 294.84 because I only paid for 6 out of 12 seconds of my subscription. Okay, it's working. It is working. This is pretty funny, actually. Come on, people. Okay, let's do the update wallet dance here. Let's deposit one near again. So 294 is going to go to 234.8 something, maybe. Let's check that out. Okay, and let's handle withdraw. Watch it. It didn't update automatically. I don't know why it's not updating the wallet. Can't explain. But 293.84 should go up to 294.3. No. 293.5. 294.4. Close enough. So I want to see that money come back right away. So I don't know what I can do to trigger that update wallet. Wallet dot. I don't know what I can do to get this component to refresh. Oh, because it's the same wallet. It's the same wallet component. It's the same wallet object, I think. So this is just like a React bug, really. Let's do this. If wallet.balance changes, let's update the wallet component by doing this. We'll kind of just like hijack this. I hope that'll trigger it, but I'm not really confident. So handle deposit. So I'm going to deposit again one near, and I'm going to quickly press withdraw. Huh? Oh, come on. Oh. Share. Now that's definitely not going to let me withdraw now because too much time has passed. Thanks, React. I'm just kidding. Okay. One more time. The button should be around here. Get ready to pounce. Should have made it a little longer than 12 seconds, right? Maybe? Withdraw. Okay, hopefully. Money back. Money back. No! Why? Why not? I don't know. I thought I dispatched blah blah, you know. I am sorry I can't update the wallet for you. I mean, really, it should update. It's so weird. Even after it's not successful, it should call update wallet. Yeah. 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 Super weird. Okay. So, unfortunately, I can't get the wallet to refresh for you. But you get the basic point. Okay. So, we didn't end in a big cheer. We ended in a bit of a whimper here. But the basic point is there. This is cool because we know that subscriptions, which are getting updated now, fall under these periods. Whoa, really? 51 for that one? That's really weird. They're all out of order. What is going on in terms of their created time? Funky. It should just be kind of in a linear order here. Maybe I'll I could sort them by time created, but anyway, let's not do that. So the point of this is that you can make a deposit to a contract. You can, let's go through the contract actually one more time. You can subscribe to something, and at that point you will push a deposit onto the blockchain at a created timestamp. You can ping and update that deposit object to track how many intervals you've paid for out of the sort of total period, or whatever you want to call like a full period. You can calculate those paid periods, and you can withdraw some amount, and you can panic if you're not less than a full period. So if you had passed a full period, your subscription would be fulfilled. So otherwise you will get portions of your subscription back. So this is then live app review. We just did a subscription contract. Didn't take that long. And sorry, a subscription kind of app. Not perfect. Lots of room for improvement here. But I hope you got the basic concepts of using block timestamp, because that is the important thing. And that is a pretty cool thing that we have in the Near protocol. What other things could we do with block timestamps? And you might be asking, oh, you know, block timestamps, they're not really super safe, blah, 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 blah. I've heard about not using time before in the blockchain. That is true in some other protocols. So in Ethereum, it follows like this, I think still follows like a ghost protocol, and there's like chain reorgs and things like that that can happen. So basically what that means is that there's multiple blockchains being kind of created at any one time, and you can't guarantee that this chain of the most recent blocks would be included. So you'd have something like 15 seconds times some amount, some number of blocks that you can't trust the timestamp, because the miners of those blocks could actually lie and change your timestamp. So that brings us to Near protocol. So we have 1 second blocks, and we have a system in which it's something like 1/3, 2/3, something validators have to be honest, dishonest, something. You'll have to check it out for yourself. But we have 1 second blocks, 2 second finality, and I believe that our timestamps, I'm not exactly sure the range in which they can be trusted, but if you're thinking especially around sort of like the I think even like, you know, the monthly, definitely, the daily, definitely, in terms of like taking out subscription deposits. I think definitely hourly, minutes, probably, you know, fairly secure. I think pretty secure. And seconds, I'm not sure. But this should handle you for most subscription use cases. So you can just do everything in terms of time if it doesn't have to be, you know, ridiculously accurate. So I hope you enjoyed. Once again, please visit us at near.ai/docs. And this can be your jumping off point for all things development. If you want to see more videos like this, you can go to tutorials and check out the videos down at the bottom left-hand side. But the develop page is kind of your main jumping off point to everything Near. And also be sure to check out the community page. Check out us on Discord, Telegram, Twitter. Follow us. Check out all our code is open source on GitHub. So all of these examples have been coming from the Near-Apps organization. So we have a lot of repos here that you can clone. These are all open source, all open license, totally free. Just go grab them, steal them, and make some cool shit. All right. Thank you, everybody, and thanks for tuning in.